Hello and welcome to Chemistry 1. I'm going to be talking about chemistry, of course, in this series, Chemistry 1. So, the most important particle is called neutron. The neutron has no electric charge. So, yeah, it's got no electron charge at all. All atoms basically have neutrons in them, and it's a different amount of neutrons. But of course, atoms they are charged things, so there needs to be a charge. And within the neutron, the neutron, we have protons as well, basically, and protons they do have an electric charge. So we can say that their electric charge is like +1. Then we have the electrons, and the electrons end outside the nucleus. The nucleus is massive and it's fucking in the middle. The nucleus is massive, it's in the middle. Electrons, I could just pluralize that maybe. Neutrons, electrons. It's like a big cloud, like a big cloud of stuff all round in the atom. So an electric charge is -1. So we got no charge, +1 charge, -1 charge. Now if I just change the color actually, we can also talk about their mass. So yeah, these are all relative. It's all relative to each other. So the relative mass, right? Neutron, big. Proton, again, same sort of, big. Electron, is negligible. So yeah, so they're the. Okay, so let's move on now. So the next thing I want to talk about is the charge. So obviously I spoke about the charge. It's like it says, I've written it's like +1 and -1. Go back to red, like here. But if we want to quantify it, we can say that the proton it's going to be 1.602 times 10 to the minus 19. So we'll just put positive there. And then we got electron. Let's make that box a bit bigger, like that. 1.602 times 10 to the minus 19. Negative. Yeah. So obviously, so that's about right. And yeah, a proton is also 2,000 times as heavy as an electron. So if we look at the mass, let's get that. So yeah, the reason it's negligible, I suppose it could. I mean, it could almost. Yeah. I guess I should really quantify that a bit better then. There we go. Rid of that. But anyway, so if we want to quantify that, so yeah, the proton mass is proton mass is going to be 1.673 times 10 to the minus 27. So it's 2,000 times. If it's 2,000 times bigger, that's going to be 3 orders of magnitude smaller. So it'd be somewhere minus 30, I guess, in terms of weight. So kilograms, and I'll put the charge here. All right. So yeah, an electron's 2,000 times smaller. I just make that. Oh no, I don't want to do it like that there. 2,000 times lighter. There we go. So what's the next thing to talk about? Well, the next thing I can talk about is atomic number and mass number. Seems like a good idea. So I don't want to use different colours, but well, doesn't really matter. So we've got the atomic number now. There we go. Atomic number, and for the atomic number, we'll represent it with Z. And this is going to be equal to the number of protons. Yeah, the difference is, of course, that I'll talk about this in a minute, actually. So the number of protons is the atomic number. So yeah, so because it can be, yeah, number of protons in the element nucleus. There we go. The element nucleus. And it can also be the number of electrons in a neutral atom of that element. So number of electrons in a neutral atom. Because yeah, if there's different numbers of neutrons, if there's different numbers of neutrons, that we're dealing with something called isotopes, which I'll get into in a minute, in a neutral atom of predefined elephant. I was going to say elephant. There we go. Right, so that's Z, and that is atomic number. There we go, atomic number. So yeah, that's how you're gonna sort of categorize them. So next thing, you know what? I'm thinking I'm just gonna stick with red. All right, so now we've got the mass number. And that is A. Yeah. So mass number is equal to the number of protons plus the number of neutrons. Yeah, that's what the mass number is. Within the nucleus, of course. So yeah. Okay. So isotopes, as I just mentioned, Okay. So atoms with the same element are not always identical. Oh, wow, W went a bit funny there. So they're not always identical, right? So yeah. So yeah. So there's going to be a different atomic mass. Yeah. So there's a different atomic mass for some atoms of the same element. Yeah.